In part one, I dealt with the base, the general support, and the arm support. In this part two, we're going to continue with the construction, placing the arm support up, showing the design of the arms and putting them in place. The spring will be there and a couple of the other things. And let's do this. Now continuing on our assembly, our drill powered scroll saw. Before we put this on, there's one other thing that I failed to mention previously. This is going to be the axle for the arms. And this is a 4-inch or 10 centimeter 1/4 by 20 thread bolt. And it's a partial thread. And because it's the length that it is, you need to countersink around one edge of it, just so that you can have enough space to actually grab the threads. So you can see that what I'm doing there is pushing that through, and I wouldn't ordinarily do that without the arm being in place. And then a washer is going to go on there, and I strongly encourage the use of thread lock in many of these cases, because these are moving parts and you don't want them unthreading themselves. And that's just another thing. Putting that countersink in there prior to assembly is just a good idea. Now the next portion of this assembly, and you're looking at the back business side, is to be putting the arm support in place, and you largely want to be putting that into a nice center location. And you obviously are looking at all of the pre-drilled holes that I've made there, but I suggest that you're not going to have those pre-drilled holes. And I think once you've centered it in place, the proper thing for you want to do is give it some good clamps. Make sure you're going to hold it in space very nicely. At that point, you would mark yourself off, and the way I've done it here is to mark the center lines. So come down in the middle of one of the pieces of, or both of the pieces of plywood, mark a center line, bring it across, mark it down, and then with a countersink pull it away. Oh well, you can leave it here, and then put those in place. And it takes a lot of screws. There's 16 screws that are going to be holding that, which is nice and solid. Or you might get away with 12 screws if you were going to glue it in place. And then screw all of those in and hold it nice and steady. And then you've got yourself something that's actually coming together. And the next thing to do, now that we've got the arm supports up, is to further reinforce this back plate so that it's not going to have any motion whatsoever. And what I would suggest is, although these are already drilled and countersunk, that you put clamps on there and just pre-drill them with countersinks and then go after it. And there are 9 that go on the back, and then there are 4 on each side. So this is really solidly in place. Okay, we're moving on to making the saw arms. And this is the bottom arm that I've got, and the bottom and the top arms look very similar, but there are some very important differences between them. First off, they are going to both be the same length, which in this case is 27 3/8 or 69.5 centimeters. The first thickness is 1.5 inches, and that's the thick part right at the root, and that's the axle hole, which is a 1/4 inch hole. This is an attachment where an eye bolt is going to go through, and what that is going to do is you're going to be able to put tension back here so that there's going to be a considerable amount of tension up at this end, which is where the coping saw blade will be attached. And this whole thing is based on using coping saw blades, which are inexpensive, readily available, and work pretty nicely. A little more durable than a typical scroll saw blade. And you can see that there is a cut down here, so it's going down to approximately 3/4 of an inch. Let's see if that's just, yes, that's the drawing calls for 3/4 of an inch, or 20 centimeters. And let's see what we have here. This one comes down to the same. So you're going to have approximately 4 inches where it's this dimension of 1.5, and then it's going to taper from 1.5 down to 3/4 inches. And this could taper, I suppose, but it's got more of a rounded hollow into a flat. So those are the things that you're looking for. The location of the drive connection is, looks to be 4 3/16, and you're also going to need a 1/4 inch hole, which is centered something on the order of a 1/2 inch or 12.5 millimeters from the end. And what that is going to do, and you're going to have to make a cutout there so that this fixture can slip in there, and that's going to be how the coping saw blade attaches. And that should be fairly tight. When I cut that, it was a little loose for the material I had, so I had to shim it, and you can see that it was pretty tight, and that's the way it should be, because you don't want this flopping sideways while you're cutting, because that just gives you a sloppy cut. Now, what's different about the upper is that you don't have a hole here for the drive axle. This is going to be actuated simply because the lower arm is pulling it down, but what it's got up here is a connection for this 6-inch spring, which will connect through there, and what that does is it pulls the arm back up. The blade pulls it down for the cut action, and the spring pulls it back up to get into a new position. So that's the difference between these two. Obviously, you still have the eye bolt going through there. Those two things will be connected with a stiff wire of some sort, and that's what it looks like. So I'll start to put that into the holders, and you can see a little bit better about what's going to happen there. What you can see for holding the spring in place, I've got two fairly sizable, it looks like those are 1/4 inch bolts, and those are threaded in there, and that's what's going to hold that spring in place. So I'll do that off camera. Now, I gave a quick preview of the coping saw holder, and these are just a couple of pieces of aluminum that I had kicking around from a previous project, but material like this can be found in the big box stores. It's near the screws, generally speaking. And that piece is what actually gets held in this location. So that's kind of the idler piece, and that has two. Well, looks like we've got two different sizes in there. Possibly a I don't know, 5/16 to a 3/8 hole, and they're going to line up roughly speaking. But what's different about the second hole is it's threaded. So it's going to be threaded for this screw. It'll go through there. Yeah, it's going to go through the top one. And catch that piece. And this is going to be a fairly active spot for threading and unthreading, because that's how you change the blade or loosen it up, so that if you want to go through a cut piece, then you can loosen everything up and then do internal cuts using the scroll saw. But what you've got are a couple of teeth at the top end of and the bottom end of the scroll saw, which will catch on those holes. So then when you tighten that down, you've got a very nice secure lock on the saw blade. And as I say, then that goes back in there, and it will gimbal to a slight extent, because there's going to be some relative motion. It's not exactly secure, so there has to be a little bit of motion, but you can see how that is built. It's pretty straightforward. Now the reason that I'm putting the arms on at this time is because the location of the axle, the drive axle, is going to be based on the location of this hole. And the whole axis of the drivetrain should be exactly in line with that hole, so that as the actuator goes, it goes in a perfectly straight up and down motion. So you can see that there is a little bit of play, but not much wobble in there. And in fact, once you start to tighten these down, you can take that play completely out. And this is an excellent spot for thread lock on these, because they're moving so much, they do tend to unthread themselves. Again, this bolt is just threaded into the wood. It really doesn't have to come out very often, if ever. So threaded wood works just fine. And there you can see the action of what that spring does. It counteracts the force, so that as the drivetrain pulls this down in the sawing motion, it can't push it back up, so the upper arm actually has to pull it back up, or else it would bind the small coping saw blade. So that spring is really important. And when you get down to it, having these two things move just like that, you can see there's a little bit of relative motion from the front end. So these have to be able to gimbal slightly in one plane. But there it is. You start to see that this is becoming a scroll saw. Now this is the reason why I put the arms in at this point, because I want to locate the drivetrain axle line. So that's the attachment spot for the horizontal portion of the drivetrain, where it's going to grab a hold of the lower arm. So just using a square, I've marked the lower location of where that is. And that indicates the axle line. Okay, that wraps up part 2, which is the reciprocating arms for the sawing action. Part 3 is going to be the drivetrain, and that's a pretty important piece to make the whole thing work properly. Come on back. Thanks for watching.